Hi, my name's Aileen and I'm on the marketing team here at OWL Cyber Defense. Welcome to OWL Solution Series, where we discuss the various OWL products, its use cases, capabilities, and features.
Hi, I'm Scott Coleman. I'm VP of Marketing here at OWL. The real purpose of these videos is to make sure that we get beyond the technical jargon, beyond the technical specifications, really let people know how the products are used and what the users are doing them in the field, the actual use cases for those products.
Today we'll be discussing OWL's XD Air solution, which is a standalone kiosk that provides security for portable media threat protection. And it's the only approved U.S. Cyber Command tool of its kind.
Right. This was a product developed in conjunction with the NSA originally to help provide safe transfer of portable media files and data from one network to another. It really protects against media-borne threats, data-borne threats, and supply chain threats. And we'll talk about that a little bit later. The other important thing here is to think about the files themselves. They're not just moving across the hardware platform, they're actually being copied. So a copy is taken from the original media, it is deconstructed, inspected, scanned, etc. And we'll talk a little bit about that more in detail later. And then it's then deposited on a clean set of media on the other side. So you get it's different than just moving the file across. It's a copy, deconstruction, and then put on the safe side.
Speaking of how it's used, can you run through a couple common use cases?
Sure. So there's two primary use cases really in the Department of Defense. Is really on base where you need to move data content from one network into a more sensitive network, and you want to make sure that those we mentioned before, the media-borne threats aren't there, and that the content threats aren't there. So you're getting content moved across, and it's put into that sensitive network without any kind of threat coming with it. The other use cases we see is critical infrastructure. The most common one is the nuclear power industry, where you've got a nuclear power plant. Nuclear power plants are completely isolated from the internet, but there's still a need to move stuff, files, patches, software updates into the plant. How do you do that if you're not connected? So you do that through a device like this. You've got a kiosk, you'd put in that known good, that known source file that comes with a digital signature. We verify the signature, we can do other inspections on that capability and move it across. So you've got the DoD bases, and then you got critical infrastructure doing the same kind of functionality.
Okay, so now that we know where it's used and how it's used, let's open it up and take a quick tour.
Sure. So this we've got is a hardened unit here today. It could be a hardened laptop like this, or it could be runs a regular PC desktop. So if I open up here, I can show you some of the components, and we'll walk through those. Yeah, so if we take a tour, this is a single-use, single-purpose device used just to moving media content. So all the ports and devices that aren't being used for the purposes of scanning and moving media, I've been locked down or disabled to prevent them from being used for other purposes. In terms of actual use, you can see in the screen the illustration here showing that you could either use a device on either side, media, different kinds of media content on the other side. For purposes here, I've got a source USB, which I plug in here from my source port, and then I've got a separate destination USB, which would go down over here on the other side of the destination. Obviously, this needs to be a clean USB that's trusted, and if it's not, then we can actually run an algorithm against it to clean it if necessary. But in terms of operation, it's plug in your source, your destination, and start your scan.
So we talked about how the physical ports themselves are locked down and secure, but what about the operating system? What's the security like?
Yeah, so it's a hardened operating system. It's one of our core competencies at OWL is the ability to lock down the operating system, unlike a Windows environment or something where you would need to do additional hardening to meet NEI or government regulations. In the XD Air, when you turn it on, there's no access for the users to get to the operating system. It boots up right into the user, directly into the user interface, and then you start using the application. There's no way to escape out or do other things. So it's a single-purpose, dedicated device that can only do perform the functions that it's designed to do. I mentioned the knowns, and we sort of described what they do, but let me get into the actual description of each one to make sure it's consistent. So known good is when we break down the components of a file, We mentioned Word documents, PowerPoint documents, into those discrete components, knowing that those components can be paired to something that is good, and only moving those good components across before then recompiling it. So you know for sure, 100%, that in that environment, only known good elements are getting across. The known bad, by definition, is antivirus detection. It's looking for things that are known to be bad already, things that have been identified earlier through cooperative measures, etc., and then a signature has been created to look for, search, and identify anything coming across. So it's searching for the known bads. And then, of course, the known source is, like we mentioned in the nuclear industry, is when you need to move a file in, it's digitally signed, and you want to make sure that that file gets in there, and while it's in transit, nothing's happening to it.
Okay, so we have three knowns. Known good, which passes good data.
Right. It's almost like a data whitelist, where only thing good gets across.
Known bad, which scans the data with antivirus scanners.
Right, and this is really basically what our competitors are doing. They're just doing the antivirus, so they're only looking for, or only picking up on things that have already pre-existing to be known bad's bad. So if there's something new that's bad and the signatures don't reflect that, then it's going to get right through.
Okay, and then known source, which validates the signature to make sure it hasn't been manipulated.
Right, exactly. You don't want to make sure when it was in transit that nothing happened to that file. Right.
Okay, and then we have the data processing pipeline, among which is the content disarm and reconstruction.
Right, so that's the complex module methodology that we use. I described that a little bit, and where we're breaking down into discrete components, and that it's really applied to a bunch of these complex file types that we mentioned earlier.
Okay, so can you expand on the complex file types and what other file types are supported?
Yeah, sure. So complex file types, like the PowerPoint example where you've got embedded images with metadata, Excel with macros, etc. It's a known structure, but they're complex. Same thing with Word documents, Excel. So there's a bunch of Microsoft products that are supported, obviously. You could use things like Adobe PDFs, XML schemas, compressed files like zip files, etc., images like JPEG, PNG, etc. So those all fall in that category, and they would all be handled by the content, the CDR process, basically.
And before you mentioned, you used a USB stick as an example for a supported media type. Are there other media types that XCR supports?
Yeah, so basically on the side here, any of the hardware interfaces that are supported would be supported in terms of allowing content to come across. So it's not just the USB, and we can go through each of those. So we've talked about the different features and functions of the product, how it compares to competitors, how it's different than competitive products. We've talked about the use cases, how it's used in both the DoD environment and in critical infrastructure like nuclear power plants. We've got thousands of these deployed both domestically and with our Five Eyes nation partners. Why don't you wrap up with just a couple of key features of the product itself?
Sure. Well, to start, it's as easy as opening it up and turning it on. It's a self-contained solution, so it's a combination of hardened hardware and software. It supports a variety of complex file types, which in turn allows it to apply across missions, such as ones that require a hardened enclosure like this one.
Right, and then the best feature is that you can take it with you.
All right, I think that's a wrap. Our sales engineers are always available to provide you a demo, so if you'd like one, you can reach out.
Right, and of course, we're always available on our website via chat or through our contact us form. Either way, we'll get back to you as fast as we can.
Thank you for watching, and if you're interested in other OWL product videos, they're available on our YouTube channel and on our resource library on our website. Thank you.